Hi everyone, you're about to learn the sets of numbers. In mathematics, there are different types of numbers and sets of numbers. First one is the counting or natural numbers. This is the set of numbers also known as positive integers and denoted by n. The set of counting or natural numbers include the numbers 1, 2, 3, 4, 5 up to positive infinity. And remember that counting or natural numbers always starts with 1. And for you to easily remember, come to think of it, when we are counting, we always start with 1 and we never start with 0. And take note that 0 is not included in counting or natural numbers. And this is the visual representation for the sets of numbers. So there is the counting or natural numbers. The second set of number is the whole numbers. These are the counting numbers together with 0, also known as non-negative integers, and is denoted by W. The set of whole numbers includes the numbers 0, 1, 2, 3, 4, 5 up to positive infinity. Okay, so in here, this set of numbers, so whole numbers are just counting or natural numbers with 0 being included. And this is the visual representation. So as you can see, we have here the whole numbers and it includes the counting or natural numbers. Kasi nga, whole numbers are just counting numbers with 0 being included. Okay, let's proceed to the third one, which is the set of integers. This set is the set of whole numbers and the negative of the counting numbers denoted by z. So the set of integers includes all the numbers from the negative infinity up to negative 2, negative 1, then 0, 1, 2, up to positive infinity. Integers includes all the whole numbers and their opposites. And it also includes 0. The opposite of 1 is negative 1. The opposite of 2 is negative 2, and so on. And both of these are integers. So here's the visual representation for integers. So we have there the integers. So it includes all the opposites of the counting or natural numbers, and then inside it there are the whole numbers, and inside it there are the counting or natural numbers. Let's proceed to the fourth one, the negative integers. This is the set of integers that do not belong to the set of whole numbers, which is denoted by this symbol. It's like z raised to negative, okay? The set of negative numbers includes the numbers from negative 1, negative 2, negative 3, up to negative infinity. The fifth is the rational numbers. As the name implies, rational includes the word ratio. So, this is the set of numbers that can be expressed as the ratio or fraction of two integers and is denoted by Q. And the set of rational numbers is A over B, such that A and B is an element of the integers and B is not equal to 0. So we have here examples: 9, 1.3, negative 17, 0.33333, 0.001, and the square root of 9. And let's take a look at these examples as to why are they rational numbers. Remember that fractions are type of ratios. So rational numbers are any numbers that may be expressed or written as a fraction. So we have here the whole number 9. So this could also be written as 9/1 in fraction. The decimal 1.3 can also be written as 13/10. The negative integer negative 17 could also be written as negative 17/1. The repeating decimal 0.3 could also be written as 1/3. The terminating decimal 0.001 could also be written as 1/1000. And the square root of 9, which is equal to 3, which is a whole number, could also be written as 3/1. So, that's why these numbers are rational numbers, because it could also be written as a fraction. Let's now proceed with the sixth set of integer, which is the non-integer fractions. These are the rational numbers which are either terminating decimals or non-terminating repeating decimals denoted by z prime. Examples: the terminating decimals, we have 1/4, which is equal to 0.25, 1/2, which is equal to 0.5. So terminating decimals, meaning it terminates or it ends. While in the non-terminating or repeating decimals, we have 1/3, which is equal to 0.3333, and so on, and 7/6, which is equal to 1.166666. Okay, so non-terminating or repeating decimal, so it never ends. While on the other hand, if a decimal does not terminate and is not repeating, then that is called an irrational number. These are the set of numbers that are not rational, denoted by Q prime. The set of irrational numbers is x, such that x is an element of the real number wherein x should not be rational. Okay. A non-terminating and not repeating decimal is an irrational number. So, for example, pi, it has a value equal to 3.141519 and goes on and on and on. And it does not repeat and it doesn't end. Therefore, it is an irrational number. Another example is the square root of 2, which is equivalent to 1.41421, which also does not repeat and does not end. If you're going to look at the chart here, we have here the irrational numbers and on the other side the rational numbers. And these are both included in the set called the real numbers. Real numbers are the set of rational and irrational numbers denoted by R. So real numbers are literally all the numbers that you could think of. Okay, so let's have an example. So we have here a Venn diagram of the examples of the rational and irrational numbers. And as you can see, these two sets of numbers do not intersect. It's because there is no number that can be both rational and irrational. So it's just one or the other. And that ends the lesson for sets of numbers. Thank you guys for listening, and we hope that you learned.